The napkin ring pictured in the following figure is to be resilvered. How many square millimeters must be covered? Okay, so we're given this figure, this napkin ring, and it's got this inner cylinder where the napkin goes in, and the outer cylinder, and then of course it's got this top ring and another ring on bottom. Okay, and you should notice that we have two different units of measurements. We have millimeters and we have centimeters. So we want to change those all into one unit of measurement. Now, if we change into centimeters, you're going to start getting into decimals because this is 3 centimeters, but the outer radius from the center all the way to the end is going to be like 3.3 centimeters. So you're going to get into decimals. So if you want to avoid decimals, which I do in this problem, let's change everything into millimeters. Okay, so instead of 30 centimeters, we'll say that this inner radius here is 30 millimeters. Okay, and that means that the larger radius, we'll put it down here, from the center all the way to the outside of the ring, is going to be 33 millimeters. And we'll say the height, instead of 2 centimeters, we'll say that that's equal to 20 millimeters. Okay, so we have everything in terms of millimeters so we can avoid fractions in this problem. Okay, so the first thing I want to do is figure out what this top surface area is. In order to do that, I need to figure out what the area of the larger circle is. So I'm going to pretend that there's not a hole in the middle. I'm going to pretend that this is just a cylinder with one big circle on top with a radius of 33 millimeters, okay, as we have here. And then I'm going to subtract the inner area, which has a radius of 30 millimeters. Okay, so the area of the top is equal to the larger circle minus the smaller circle. So large circle minus, move over a little, the smaller circle. Okay, let me zoom out a minute. Okay, so the large circle, remember the area of a circle is pi r squared. So we have pi, our r of the largest circle is 33 squared. And then minus the small circle, which is pi r squared, but this time with a 30 radius. Okay, if you multiply this out, 33 times 33, and do all the math on that, you will get 189. And then the pi just gets carried along. Okay, so that's the area of the top. Now notice that the area of the bottom, it's kind of hard to see these little dotted lines here, but the area of the bottom is going to be identical to the area of the top. So this is identical. If you flipped it upside down, the ring would look the same. So we'll say the area of the bottom is also equal to 189 pi. So we don't have to do that calculation twice. All right, that takes care of that. Now let's look at the inner ring. So this inner part is also getting covered with silver. Okay, so we need to know what is the surface area of this inner ring. And how I do that is I find first the circumference of this inner ring. That's 2 pi r. We have the r, that's 30. 2 pi times 30. And then I multiply it by the height. Okay, so it's basically, if you laid this out, this would be a rectangle. Okay, if you were to cut this ring open and lay it flat on the ground, it'd be a rectangle like this. Okay, and the height of that rectangle is going to be 20 millimeters. Comes from here. And the length of that rectangle, that's the reason we're finding the radius. We're finding how far it is to go around this thing, because around this is from here to here. Okay, and that's where the circumference is, 2 times pi times r, which is 30. So 60 pi. Okay, so the inner circle is equal to 60 pi times 20. So you have 1200 pi. Okay, so this is the inner. Okay, let's do the same thing for the outer one. I'll make it a little bigger. Okay, again, we want to find the circumference of this thing. So the circumference with now a radius of 33 is going to be 2 times pi times 33. The height is still going to be 20 millimeters. Okay, and this is also in millimeters. So that's going to be 66 pi times 20. So the outer circle is equal to 66 pi times 20, which is equal to 1,320 pi millimeters. Okay, so the total surface area is equal to 189 for the top, 189 pi, plus 189 pi for the bottom, plus 1200 pi for the inner circle, plus 1320 pi for the outer circle, which gives you a total of 2,898 pi as your surface area of this napkin ring.